questions. Jesus. If I only did past questions. That means you came across a question on hormone now. So let me ask you hormone. Which one of these hormones are referred to as tropic hormones? Option A, estrogen. Option B, adrenocorticotropic hormone. Option C, thyroxine. Option D, what's the name of this hormone? Calcitonin. Yeah. What's the answer? Which one of them is referred as a tropic hormone? You are not sure. You are not sure. Now, do you know the answer is in the name? Which one is it? Adrenocorticotropic hormone. Okay. Well, yeah. Yes. So, yeah. What's a tropic hormone? Good. A tropic hormone is any hormone that is secreted from an endocrine gland to another endocrine gland. And there are 4 of them. How many of them? 2? Yeah, 4. Flat. How many of them? How many of them? Flat. Follicle stimulating hormone, luteinizing hormone, adrenocorticotropic hormone, and thyroid stimulating hormone. Yeah. These 4 are produced by the anterior part of the pituitary. Una know now? Una never do. Una don't do one. Una don't do one, ba? Yes. Una don't do one now. Vasopressin, where is it produced? Jesus. Vasopressin, where is it produced? Okay, antidiuretic hormone, where is it produced? You know that's the other name now. So where is it produced? In the eye. In the nose. Where is it produced now? In the stomach, what? In the kidney. Where? Nah, that's not how it works, man. You all are supposed to be smart kids. I believe in you too much. Jesus. You are believe in you, you don't even believe in yourself like that. I'm being honest. I believe that you guys are very, very smart. I will keep saying this. The teacher is not the smartest person in the class. I'll keep saying it. It's tomorrow. One guy, one class, like I want to teach somewhere, and one guy was talking. He was like, I'm the smartest person. All of you are 80. And I'm the only person that has sense. I was like, the fuck, bro? It doesn't make sense. Understand? And the guy take bow in class. What did I say? He's take bow. You know what bow means now? So bow means you said something that was not entirely correct. You get what I'm saying? So I don't believe that the teacher is the smartest person in the class now. I believe that the teacher probably has more experience than you, more exposure than you, but smartest person, nah. There are so many dangerous people here now. What did I say? Dangerous people, and you are one of them. True about? You're one of them. So I believe you guys should be able to push more than we are even pushing. Are you guys following what I'm saying? So please, if you are not reading before, start reading. What did I say? What's the answer to that question? Yes? No. I'm asking. You know, you are still something that question. But you marry yourself. Koye with a good answer to that question. You got 25 CMQ. Okay. Now we're going to take that question before we come back to what we have for today. So I was saying something. Vasopressin, for those of you that read biology, is antidiuretic hormone, and it is produced in the pituitary gland. Am I communicating with you? So that's basically. Coming back to Go on. Code one question I can literally pass. Want to really go? You are not really listening like you want to pass. You listen like you want to pass. Want to really go? Okay, so listen. Let me tell you one thing about all this kind of questions. Once you see it, listen, calm down. We're going to go back to what we have been studying since yesterday. But listen, let's grab this now. Listen. Is take it one by one. It involves a reaction. So class, I'm asking a question. Does this question involve a reaction? What is reacting with what? HCl is reacting with calcium carbonate. I mentioned this in yesterday's class. That anytime an acid reacts with a carbonate salt, it has only 3 products. What are those products? Salt what? Carbon dioxide and let's get to it now. It's very simple. We are finished solving this question. CaCO3 is reacting with HCl. And we said this guy will collect hydrogen's girlfriend and become calcium chloride. Then you form water and CO2. Finish. That's all. Now, balancing it. You don't even need to balance it because you need to balance here. I thought it was calcium I gave you the value for, but all the same. All the lab balance. Now, let's now look at the question properly. Sorry, before we look at the question. The second thing is, once you are giving this kind of question, please listen. Check. What did I say? That is to say, which of these substances has a given numerical value? Then the second thing you check is, what am I expected to find? That's what you need to take note of. So let's look at this now. Class, according to the question, what are we expected to find? So this is the expected substance. Now, what substance were we giving a numerical value for? Check. CaCO3. Can you read the question? Let's find out. 1, 2, ready, go. When calcium carbonate, were you giving any numerical value for calcium carbonate? So you are not giving calcium carbonate. So go on. When calcium carbonate reacts with what? Dissolved in what? 50 cm cubed of 0.1 gallon of what? Good. So which means this is the person that we are giving. Is it not? And that's one you relate. Now, stoichiometry is simple. It's just like cooking. Listen. 5 cups of rice in the nation. How many cubes of margarine should you use? Let's say 2 bar. If I'm now cooking 10, how many are you going to use? How many are you now going to use? 4. Please leave your cooking mentality and use maths. If 5 is 2, 10 is how many? 4. Now listen. If I now say 1 painter, please, are you going to just cross multiply like this? Excuse me, are you going to just cross multiply like this? What is the first thing you need to do? Convert this painter to what? To cups. And let's say in 1 painter there are 20 cups. Let's just assume. So if there are 20 cups, how many margarine are we now going to use? You may cross multiply. Or 5x equals 20 times 2 divided by 5, right? And when you do this, this is 4 times 2, and that is equals what? 8 cubes. Did you understand this simple mathematics I did? That's what we're going to do. Now, you have that the given is 2HCl. The expected is 1 mole of CO2 in deputy. So listen. On a normal, if the reaction is to occur, 2HCl, I mean 2 moles, let's use the term moles, because when you are writing equations, the equations are written in moles, right? Are you following? Good. 2 moles of HCl was converted to produce this thing we are looking for. 1 minute. Morning, please. If you're in medical class C from the new list we released, please go there now. Check. If you score 250 and above, move to medical class C now. We have serious things to do there. Then those people in Med C that did not meet the cutoff, they will return to your class. We'll do welcome party for them. They will come back. Please. Okay, are we done? Hello? Yes, start leaving, please. Okay, thank you very much. Now listen, let's continue. Listen, let's continue. Hello? Now, as I was saying, please listen. Right? And what it normally gives is 1 mole of CO2. Abi? Good. Now, our question now says 50 cm³ or 0.1 molarity of HCl will now give what? What did I ask? X cm³ or dm³? cm³ in whichever one. Let's say it's in dm³. Let's say it's in dm³ of what? CO2. Now please, to solve this thing is very, very easy. What you need to do is, you know that the two of them have to be in the same units now before you start cross multiplying. That is to say, if here is mole, this whole thing should be converted to mole, right? And then if here is dm³, this too has to be converted to what? dm³. That's the only thing you need to do. So let's do the conversion. How do you convert molarity and volume into number of moles? Very simple. N is equal C times V in cm³ divided by 1000. I presume you should know this now. This is one of the things I saw. Who taught you this? Either massacre or promise. I've even forgotten. But I saw it on your board one time. So please, if you don't know this, put this down. What are you trying to do? You are trying to change these two things so that it becomes what? Moles. Or yeah, somebody should do it for me and give me the answer. So do it and give me the answer. Yes. Why it's taking this time is because I'm explaining this. If I solved it, I would have gotten the answer a while ago. Oh yeah, are you done? Are you done? What do you have? 0.005 watts now. Moles of getting HCl. Okay, so let's look at this. What this means is that instead of using these guys, what are you now going to be using? 0. You know we're just going to cross multiply, sure you know. Now let's come here. Here is a mole, here is a dm³. You cannot cross multiply unless the two sides are the same thing. Am I communicating with you? Now, because we are looking for our answer in dm³, it means that you need to convert this mole to what? dm³. So let's convert it. How do you convert mole to dm³? Do you remember that N is equal to V in dm³ all over 22.4? Do you remember? Yes. Which means V in dm³ is equals N times 22.4. What is N in this case? 1. That is 22.4. So instead of writing 1 mole now, what are we going to be writing here? 22.4 dm³. Can you now cross multiply? Yes. Get your answer. What's your answer? Get your answer. Yes, what's your answer? You don't know how to get our answer. So the answer is what? X dm³ of CO2 is now 0.056 dm³ of what? CO2. I know plenty of you do not understand. If you do not understand, when you get out, let's start helping you. Thank you. As your destiny. Even you. No, I don't want to wait before a question. Those that do not understand, let me see you again. Okay, very good. What exactly do you not understand? Everything. Now, see the question I have for you. You don't know what cross multiply is. Do you know what cross multiply is? Okay, let's take it afresh. What is the first thing I did? Equation, right? After I wrote the equation, what is the next thing I did? Who did they tell me to find? CO2. Who was I giving? This guy. So what did I do? I said from the balanced equation normally, 2 moles would give 1 mole. Is that not what I just did? Is that not what I just did? Please be following me. Now I now went to the question and said, if 2 moles gives 1 mole, according to the question says 50 cm or 0.1 will now give X mole. Is that not what we are doing? Okay, so back to what I was saying. As I said, if you check out the question says 50 cm cube. CO2 was done, the 50 cm cube was 0.1 something to give CO2, which means on this side we are given. These are the values that we expected to use to find the number or the volume of CO2. Did everybody understand how I got this arrangement? Because this is the most important thing. You are still confused on how I got it? Raise your hand. I'll use a simpler question to explain it. But for now, those of you that got this, I hope this is clear now how we got this arrangement. Given this side, expected this side. Sorry, excuse me. Okay, so as I was saying, please listen. Please listen. Okay, so as I was saying, please listen. Listen. You are given these things, these values. But before I began to solve, I just identified them and wrote out how many of this gives how many of this from the balanced equation. Then wrote down what they gave me in the question and then what I was asked to find. Finish. That is how we got this particular part. Now, having said that, I told you that here is not moles. Here is cm cube and concentration. But here is moles. So what do I need to do before I start cross multiplying? I need to convert this cm cube and concentration to moles. The way to do it is with this formula. So somehow just cram it or know it. Did you hear what I just said? But how was it derived? Concentration is amount of solute in a given amount of solvent. Is that not concentration? Unless you don't know concentration, which is not supposed to be my fault entirely, because you should know it by now. When you hear concentration, what is concentration? Solute divided by solvent. And that's this. C is equals solute divided by solvent. Now, if that concentration is in volume in mole per, that's in mole per dm cube, it means that it should be number of moles over volume in dm cube, or number of moles over volume in cm cube, but you now do times 1000 over 1. Make n subject of formula. What are you now going to get? This. I am just giving you a formula that you can use straightforward to convert this concentration, which is 0.1, and volume is cm cube, so that it will now be called what? Number of moles. That's what we did here. So put all these things inside here. You will have n equals, what's the concentration class? 0.1. What is the volume class? No, 50. What is the 1000 class? 1000. After doing it, what do you get? This. Why did I have to convert these two things? So that here will be mole and here will be mole. Did you get what I just did now? This part. Did you get this part now? Good. Okay. Now, we come to this side. Listen. The balanced equation, when we checked, here is in mole. But the answer we are looking for is in dm cube. Can I cross multiply? No. I need to make sure that anything that is here is the same thing that is what? Here. So what am I going to do? I'm looking for the answer in dm cube, which means I need to convert this other one. And how do you convert mole to dm cube? Unless you don't know more concept. If you know more concept, you know that n is equal to b in dm cube over 22.4. So I just did this one mole that is here. Make it subject of formula. Make volume in dm cube subject of formula. It becomes n times 22.4. So this one mole is what I'm converting. I put it here. 1 times 22.4. Please, what is now my answer in dm cube? So instead of writing 1 mole, what did I put here? 22.4. Cross multiply, because this is now dm cube, more mole. Can I now cross multiply? Yes. Let's cross multiply and get your answer. That's all. Now, the reason this seems a little bit confusing is because I intentionally gave you multiple different units. It's intentional, so that I can be able to touch all these things. Okay. Now, can you try out one question? Try. See if you can get this. Now write, everybody. What is the the mass of magnesium required to dissolve in sulfuric acid to produce 4.48 dm³ of hydrogen gas. To produce 4.48 dm³ of hydrogen gas. Class, what did I say is the first thing you do? Check if that question involves a reaction. Is that not the first thing? Then if it involves a reaction, you write a balanced equation for the reaction. Everybody write that down. Write the balanced equation. What does it give you? What is reacting with what first? Magnesium is reacting with what? Magnesium is reacting with what? Okay, very good. What did I say about the reaction of an acid and a metal yesterday? It liberates hydrogen gas. So magnesium will collect hydrogen's girlfriend and become MgSO4, and hydrogen will be alone. Abi? Is it balanced? Yes. Okay, who is the given? Who is the expected? Check your question before you answer. What substance were you giving a numerical value for? Hydrogen gas. So this is the given. What substance were you asked to find? A mass of magnesium. So this is the expected. Which means I will simply say 1 mole of magnesium. Is this balanced? Yes. Equals 1 mole of hydrogen. Don't be so. Therefore, according to the question, how many grams of magnesium will now react with to produce what? 4.48 dm³ of hydrogen. Class, can I cross multiply like this? What am I supposed to do? Convert this mole to gram, and maybe convert this mole to dm³ or dm³ to mole. Anyone you want to do, it's still the same thing. Now, how do we change mole to mass? N is equals mass over molar mass, which means if you want it to be in mass, you do N times molar mass. The molar mass or atomic mass of magnesium is 24. So solve. You already know how to convert mole to dm³ now. How do you convert mole to dm³? E equals what? N equals what? V in dm³ over 22.4. Or V in cm³ all over 22,400. 4.8 grams. Somebody got 4.8 grams. Okay, that's possible. I think that's the answer. Sir. Is that the answer? Is that what everybody got? If you got 4.8, let me see you. Okay, thank you. Hands down. If you did not attempt the question because you do not understand anything, let me see you. Thank you very much. Okay, if you attempted the question and you still failed it, let me see you. Okay, very good. If you do not attempt the question because you just don't give a damn, let me see you. Thank you. I like that lady over there. Thank you very much. Now, for those that are seriously confused, hello, Sochima, right? You raised your hand. Who else raised their hand that they do not understand? Thank you. Very good. Thank you very much. Now, I just want to understand or clarify something. What do you not understand? Because, yeah? Yes? When you use that molarity bond, okay, is it that that formula I gave you? It's not mass, it's number of moles. What's the formula? What's the mass of solute times 1000. And that's okay. To find the concentration. Now, this, listen. The one I gave you, listen, is when the solute is number of moles. This one is when the solute is what? Is mass. Do you understand? So if the solute was given as mass in gram, you do, let's derive this set. What am I doing? Let me show you the relation straight up. It's the same thing, no? Listen. C is number of moles times 1000 over volume in cm cube, right? But you know that instead of writing N, you can put mass over molar mass. Now what happens to this N? It becomes mass over molar mass times 1000 all over VA cm cube. Have you seen it now? They are the same thing. The difference is that if you are dealing with mass, you use this. Because the unit of molar concentration is not gram, it is mole. So you need to convert this gram to mole by dividing the mass by the molar mass before you put it in your equation. Confusing? Is it clear? Good. Oh, now back to you guys that said it was confusing. Yeah, I just want to get what exactly is the issue. You don't know how to write the equation. That's number one. Okay, very good. Let me get one other person behind said it was. Are you speaking? Someone here, she was in glasses. I can't remember. Yeah, one of you, yeah? I want to clarify. Yes, it was confusing. You didn't get this. Who did not get this thing? I've gotten one point I need to clarify. That's the equation. I don't know how to write it, yes? What's your own problem? You don't understand the question. Okay, first, the question. Equation. Yes? Who else is confused on what we just did? I want to clarify these things one by one because I can't reteach everything if I don't understand what is the issue. Yes? The formulas I am using. Very good. Okay, formulas, equation, question. Any other person? The conversion, which has to do with formulas, right? Where's the guy that said formulas? Oh, that has to do with formulas too. Okay, that's formulas. Okay, thank you very much. Who else? Any other confusion? Yeah? So I have gotten question, I have gotten equation, and I have gotten formulas. Now please listen. Listen. This is the last time I'm going to do this, so please listen. Thank you. Once you look at a question, let's read this question together. Everybody, once you read it. What is the mass of magnesium? Okay. Okay, so explaining the question, they said that magnesium reacted with H2SO4 and produced hydrogen gas. Please, can you not see from that particular thing I just wrote that what is reacting with what is magnesium and H2SO4? Hello, please, those that were complaining about the question. If you read the question properly, you will see that magnesium reacts or is dissolved in H2SO4, and then what was the product of that reaction? Yes, look at the question. Now, what's the product of the reaction? What was the product of the reaction? Don't look at me, check your question. Oh, you did not write the question, right? You did not write the question. Is that the issue? You wrote the question. Look at the question. What is the product of that question? Hydrogen gas, not be so. So, if you are writing the equation, now I'm talking about the equation because you don't understand the question. The question says, this guy reacts with this guy to produce how many of this guy? It's simple. Now, if I say, listen, if for instance I tell you 1 plus 1 equals what? Please, what are you supposed to do? You write 1 plus 1, then you tell me what the answer is going to be. Please, 1 plus 1, is it equals 3? Is it equals 4? Is it not equals 10? 1 base 2 plus 1 base 2, is it not equals 10? Yes. Hey. Yes. Unaweka binary A1 na primary school. Our primary school cake is like binary number. You did not do binary number in primary school. When did you do binary number? In just one now. Just one primary school. Now, as I was saying, let's say, my point is this. Explaining the question. It is clearly written there. Magnesium is reacting with what? Sulfuric acid. So everybody write that down. Mg plus H2SO4. Write it down. I'm explaining the question. Mg plus H2SO4. That's what the question says. Have you written that down? See as they talk, Chairman. Oh, you don't write that before. Very good. Now that we have written that, the question is, anytime a metal reacts with an acid, what is the product? I don't talk this thing yesterday. That if you look here, go and look up, you will notice that magnesium is higher than hydrogen. So magnesium will collect hydrogen base. True or false? So Mg will now become MgSO4. While hydrogen will now be alone. So complete the reaction. That's what happens. Okay, now let me give you another question. Look at it, look at it. If I say Ca plus HNO3, can you tell me the product of that reaction? Ca what? Ca will collect NO3 now. What's in there? No be am. What will be the product? What will now become? CaNO3. No be so. Then hydrogen will be what? Alone. If I say Na is reacting with HCl, what is the product of the reaction? NaCl plus what? Hydrogen gas. Is that simple? So has everybody gotten how to derive this particular equation I'm dealing with now? Yes. Okay, good. Now, the final thing, please listen, so that I'll move into what we have for today. Listen. Is that you need to understand what you are given in the question and what you are asked to find. So read the question if you have it. Look at it. What were you asked to find in this question? Not the mass of magnesium, the same way you find. So you write it expected. Why do you need to identify it? Because you are going to be rating it. Now, what were you given to find magnesium? Check. You are given the volume of what? Hydrogen gas. So that's the given. And I'm going to wipe all these things out. And before I start relating, I'm going to write some stoichiometric relations for everybody to take note of. Stoichiometric relation 1. Listen. Number of moles is equals mass over molar mass. What did I say is the first one? Number of moles equals mass over molar mass. Stoichiometric relation 2. Number of moles is equals volume in GMQ all over 22.4. What did I say is the second one? I'm talking about the formula now, bro, and the other lady. Please put this down. Yeah, these things are not, I don't know how to put it. There are some things that you just need to know them like that. Just put them for your head. And how do you put it in your head? By solving as many questions as possible. I never sat down to learn stoichiometry. How did I know stoichiometry? I just brought out questions. After reading it the first time, I started solving questions. You're solving questions. You look at the form. Don't even do cramming. Look at the formula in your notes. Be like, okay, they said number of moles to volume. You check. What is the formula for number of moles to volume? By the time you solve 100 questions, what did I say? By the time you solve what? 100 questions on that concept, you cannot forget the formula. Why you think say we teach as like this is book? Oh, you think it's because we are too smart? We are not too smart. What do? We solve the questions we solved on so many of these concepts. It don't plenty. So that's why we can just bat into class and discuss things as if we are discussing it from a textbook. You can do the same thing. How are you going to do the same thing? Solve as many questions as we are solving. And you have the same experience. If I ask you now, how many of you have finished solving all the remix questions on solubility? You are taught solubility, right? There are about 140 something questions, 57 something questions there. You solved all of them. Let me see your hand. That's the problem. You solved all gas law questions in remix. All of them. Let me see your hand. You don't have remix. Sorry, I mean or jam pack too. You don't have any of those things. You have 330. You have 0.1. Okay, very good. Now listen to me, oh. Listen to me. You have jam pack according to topics that you are supposed to have started using 2 months ago. so that by now you have finished all the questions in most topics. Why do you think we decided to design something that is topic by topic? So that you'll be sure that once you're done with the topic, there is no question that can come out from there to answer. So you still solve and then later correct the comma. Yes, now that's how it works. You get what I'm saying? You keep complaining about comma, but if I tell you that, okay, if I send a PDF of remedies to you and give you the assignment to solve all the questions on redox solubility and bring it by Monday, I am 100% sure that the number of people that will do it here will not be up to 5. I'm not joking. I'm telling you. You see, I don't do things for a while. I know it's how they talk. If you have not started doing these things before now, this is 2 weeks to jam. What do you want to jam? Anyway, listen. So I'm giving you one way to learn this thing now. I'm not saying cram it. I'm saying open questions. Look at the formula and solve. Don't cram it. Don't be like, it's not in my head, so it's not there. Just be solving. Look at the formula, solve. Look at the formula, solve. Look at the formula, solve. We're going to do naming. When I give you the rules for naming, and you want to name, please look at the rule. Apply. What did I say? Look at the rule. Apply. You must not cram these things. By the time you name close to 100 structures, if you forget any rule in naming, you will just know it. Are you getting what I'm saying? Good. Now let's continue. As I said before, number of moles is not a molar mass. What are the two things that you're getting here? Is number of moles and mass. But let me give you a question. What is the mass, the number of moles in, what's the number of moles in 2 grams of sodium hydroxide? 2 grams of sodium hydroxide. Is it not 2 grams that is mass? Sodium hydroxide, so it's 2 grams. Is it not number of moles that you should find? Yes. N is equals 2 grams divided by, what's the molar mass? NaOH. Na plus O plus H. Yeah, molar mass. Add everything. What is it? So 2 divided by 40, what is your answer? 0.05 moles. E of Velari. Or everybody, find the number of moles in 11.2 DMQ. What is the answer? Somebody said 1. God of Jesus. So those at the back are not even attempting to solve this thing. Excuse me. Find the number of moles. I'm talking to you, auntie. What's the number of moles? Oh yeah, start solving. I'm talking to auntie, not people. I'm talking to you. Number of moles inside 11.2 DMQ. Solve it. It has a specific formula. N is equals volume in DMQ divided by 20.4. No, that's not what. Wow, no. The formula is N equals volume. Write the formula now. N equals volume in DMQ. The small n anyway. Yeah, small n. Volume in DMQ divided by 22.4. Now, when is the 11.2 as the volume? 11.2, yes. And say find n. What are you going to do? 11.2 divided by 22.4. 11.2. Okay, I have another question for you. Listen, because I don't like the way you people are acting towards academics. It's paining me. Another question. What is the number of moles in 4.9 grams of sulfuric acid? Number of moles in 4.9 grams of sulfuric acid. You know you are supposed to do any course mass of molar mass. What do you do now? And the big question, you just keep on. Write down question, chairman. When I don't come class, if you don't be class, you come, just they go. You understand? You pay money for this lesson. Now you sit there like this. You pay money. Don't be about right. I give question, you write down. I pay money, sit down here, they waste time. 0 point. Somebody got 0.05. Is the person correct? Yes. Lord of Jesus. The person is likely correct or not correct? Me, I don't know. Is it correct? Yes. Alright, let's find out if it's correct. I said, listen, watch. What is the number of moles in 4.9 grams of sulfuric acid? Which means mass over molar mass. What will be the mass where they give us? Sulfuric acid is H times 2 plus S plus O times 4. No be so? So let's do this together. Hydrogen is 1 now. That's atomic mass. 1 times 2 is 2 plus 32 plus 16 times 4, 64. That's 98 bar. So that means N is equals 4.9 over 98. When you do this, what is going to be your answer? That's how to convert that's mass to number of moles. Now, how do we convert number of moles to mass? It's just subject of formula now. No beyond. Okay, very good. Sorry, I hope we are grabbing these things as we are doing this thing now. Okay, now let's take this guy out. I've not come to the question though, but let's write out all the formulas that we need to know. Number of moles to concentration. Taking a human variable concentration. Once you see mole per dm cube, once you see molarity, or you see capital M. What did I say? I gave 3 things now. What did I say? Number 1, molarity, mole per dm cube, or capital M. Imagine molar concentration. Molar concentration. And it is related to number of moles by concentration C times volume in dm cube. Now, open again dm cube. N is equal to C times volume in cm cube divided by what? 1000. You don't need to cram these formulas. Just write it in your notes. As you are using it, it gets into your head. Yes, ma'am. No, you don't need to divide by 1000. What we did here too, we divided by 1000 is converting cm cube to dm cube. Because molar concentration is in mole per dm cube. So when you have a cm cube value, you need to convert it. Okay. Oh yeah, I'll get to this. Now, having said this, are we all listening? Let's now come here. Listen. So when we have identified Nkenyerai and Nkasigichota, you simply use the balance equation to do it. How do you use the balance equation? It's your way. From balance equation now, in Afuna, 1 mole of magnesium is given. Where is Sochima's head? You press for them. 1 mole of magnesium is given how many of hydrogen? 1 mole of hydrogen. Now, Nime more is you don't get why I'm doing this thing. When you go that again. Okay, so yeah, 1 person down. Every other person understands why I'm doing this thing. Why am I doing it? Because according to the question, they said I should use the hydrogen to determine the magnesium. But then, I cannot do it just like that. I will need to use a standard value. When we were cooking rice initially, there was a standard formula. What was the standard formula for cooking rice? 5 cups of rice equals to maggi. That standard formula was from balanced equation. So from standard formula of cooking rice, usually she 200 cups. We're going to maggi only they use. Oh yeah, yes. I'm a marriage, but if I want to cook 200, how many am I going to use now? 80 maggi. How do I know that? Because I have understood that the normal way of cooking rice and maggi is what? 5 cups equals what? 2 maggi. Did you get what I just said now? Okay. Now what's this? The normal way of reacting or producing hydrogen with magnesium is that 1 mole of magnesium will produce how many moles of hydrogen? 1 mole. Of course, we're talking the normal way. Now, with this normal way, and where you see what mass X gram of magnesium will now produce what? What did they say? 4.48 dm cube of hydrogen. Is anybody confused with respect to how we set up this particular proportion? If you are, raise your hand. Because I'm going to give you a question. If you fail that question, you are going to stand up until you get a question in this class. So I'm asking this thing again. Is anybody confused on how we got this arrangement? Yes, where are you? Oh, you just said yes, so that you should be like, I'm not going to ask you the question, are you? Is that right? Now, please, what's the next thing we need to do? Can we multiply like this? No. You cannot work. We need to convert this mole to gram. How do you convert mole to gram? Who can remember? Don't cram it. Look at the board. Try on the board. How do you convert mole to gram? now gram can actually convert here, which means mass is number of moles times molar mass, right? Oh yeah, mole is 1. Molar mass of magnesium is 24. So the mass of 1 mole is going to be what? 24. Cancel this thing to get 24 grams. If you na gram, I get banned. Yes, are they the same thing? No, convert it. Are we converting mole to DMQ or DMQ to anyone you see is okay? Why we converted to gram? Because the answer is in gram, so we need to convert this one to gram. But here you can choose anyone. So what are we converting to? DMQ to mole. Okay, so DMQ to mole. Mole to DMQ to mole. Mole to DMQ. Okay, mole to DMQ, which means V in DMQ is equals N times 22.4. Not this way. So V in DMQ, this mole that is here is 1. So 1 times 22.4. So you cancel it and put what? 22.4 DMQ. Now, can you now cross multiply? Yes. Because here and here have the same unit. And here have the same unit. Cross multiply, what's your answer? That's easy. Now what I want you to do for me is go home and solve as many questions as you can on waiting in the column. What's in the column? Stoichiometry. Okay, good. I will not be available this night, but tomorrow night I'll make time. You might call it stoichiometric night. As many questions as you have on stoichiometry that you could not solve. Yes, sir. You should not. You found. And no, that's the thing. The question did not say find the mass of 1 mole. The question said find the mass that 4.8 will produce. That's why when you find the mass of 1 mole, that's like just to convert it to mass. Are you getting what I'm saying? Now, according to the question, 24 grams will give 22.4. Therefore, X gram will be produced by 4.8. You get what I'm saying? So you need to cross multiply and then get your X, because it's your X that you're looking for. Okay, now please listen. Hey, listen. I'm not sure. Maybe I'll just say hi in the group. Anytime you see me just post stoichiometric night, you guys should just start sending stoichiometric questions. If not, when we come to class next time, I'll take all your questions that you tried that you could not answer on stoichiometry. For now, we are going to get into identification of organic compounds and naming. In identification, please listen. We are going to be studying structures and how to convert those structures to IUPAC nomenclature. And we are going to be studying names and how to convert those names to structures. Am I communicating with you? Now, I want to believe that everybody that is here knows all the functional groups. Should I assume that? Should I assume that? Okay, so what are the functional groups you are sure you know? Sorry, sir. You know alkane. What is the functional group in alkane? What is the functional group in alkane? Hey, Jesus Christ. What is the functional group in alkane? You don't know, Abi? Okay. Once you are dealing with a hydrocarbon, can you have a hydrocarbon? Hydrogen and carbon. So the hydrogen, there carbon, or hydrocarbon. Any compound that contains only hydrogen and carbon is what? A hydrocarbon. Is it not? Now, if that hydrocarbon, madam, can I have your phone? Thank you very much. I don't want to shout to face too small. If you see it, you know you keep it whatever. But yeah, fast. If this will seize it, if they seize it, it will stay longer than it will stay with me. My own is, I don't want to be pressing this in class. It looks like my phone. Hey, is that a phone? Check. Is it like, is that a, it's not a phone. It's not a phone. I saw fast camera, I tell you that. Because normally, I used to seize phone and travel. Like this one I'm using now. I forgot what I used it for, but it's not in this MBA. But I traveled and I forgot. It's not I don't do it intentionally. So now by mistake I flashed the phone. I did not know. I did not know. When like my hand just, I don't know, it just flashed the phone. And then before I knew it, I just started using the phone because my other phone spoiled. So I said if I come back to you, I'll track the person. I've not had time, that's why. And then the SIM in the phone also lost. Somehow. So please, if you have iPhone, I want you to use it in class. I will not seize it. I will just collect it from you. Then later after class, now collect it. Now, what did I say about arcades? Yes, I'm talking to the young lady. What did I say about arcades? You did not hear what I said. Ma? What did I say? You can't remember. Okay, so arcades. In fact, let's just write them. Move your right and back. Because don't just see the ones that we know, the ones that we don't know. But your there's no time. So arcade. What you're gonna write is homologous series. Homologous series. Because yeah, homologous. Open your table and a note too. Yes. Open note too now. Open your notes. When did you do it? Okay, what they go? It has stayed like months. Oh yeah. Now let's do it again. Now right. For those of you that don't have it in your notes. Homologous series. See, listen. My own is just going to contain homologous series and functional. But what I want to concentrate in this class now is identification. I want you to be able to look at every structure in any past question, any year, and name anything you see. Am I communicating with you? Yeah. That's the aim today. So look up. What's the time now? 9:39. Okay, very good. 9:41. Now listen. Quickly. Listen. Okay. Single bond hydrocarbon. What did I say? Thank you. Alkene. Double bond hydrocarbon. What did I say? Alkyne. Triple bond hydrocarbon. What did I say? Alkanol. Hydroxyl group. What did I say? So bracket OH. Ether. Oxygen. What did I say? What did I say is the functional group of ether? What did I say is the functional group of ether? I am begging you, participate in this class. So, one of the reasons I engage you is simple because sometimes you might sit in class and if somebody is talking for too long, you might disappear from that class. It happens. All I'm begging, you will just be looking at the person. You are not even thinking about anything. You are just looking at his mouth shaking. We are not getting anything. All I remember more. But how do you help yourself to stay active in class? If the person says, do you understand? If you understand, say yes. If you don't understand, say what? No. Am I communicating with you? If you notice that no one you raise your hand quietly and be like, sir, I can move on lesson now. I am supposed to learn this thing you are teaching. Please teach me. True or false? Have you done to do it in this lesson? You don't tell that name for lesson now. Or free could never. Okay, it's alright. Free candidates. Let's continue. So please, what did I say is the functional group of ether? Oxygen. What did I say is the functional group of ether? Oxygen. What did I say is the functional group of ether? Oxygen. Ether put down about alkoxy something. And then see, Okumaya now. I said the methoxy. Oh, we did that now. Yes. And we said that they are functional isomers of which ones? Functional isomers of which group? Alkanols with corresponding carbon atom. Esters are functional isomers of who? Alkanoic acid. Esters are produced by esterification, which is a reaction of what and what? What is the ester produced by reacting CH3OH plus HCOOH? What is the name? Alkanol. So what's the chemical formula first of all? Wrong. This part is always maintained. Just remove this hydrogen. So what you are supposed to have is HCOOCH3. Name this part. How many carbon? This part. How many carbon? So what is it? Methanoid. So what's the name of this compound? Methyl methanoid. Openaru? Openaru? Jesus. They are the very simple. I'm not coming here they as simple as chemistry. Physics, they are simple as chemistry. You can never go to physics. Like you are still doing. Now let's continue. As I was saying, all is simple. I said we just work for you. You know, OH that come on. Onya, Abieba. Oh, we also Japan. Come on, man, I work for you. And that is a man. Maintain the side that. Oboro HCOO. Can we get the H? What will you now put here? CH3. So put CH3 here now. Then what do you add? Water. What do you add? Water. Now looking at this thing now, please listen. What do you call this thing? I said name this part first before you name this part. What is this thing now? Why is it methyl? One carbon. Then here is alkanoid. What does it say you call this part? Alkanoid. Now what alkanoid is? How many carbon is here? One. So methyl what now? Methanoid. Like that. Anyway, let's continue. Now we go to the next one, the quantity. Alkanal. Now before I continue, I just want you to write this on the side. Write it on the side. You know, please listen. You know that what's the column? Oh, what is this keeping my mind? In the lab preparation of what do they call it? In the lab preparation of what's the substance? Okay, yes, that was what I was saying. Ether. Now, in the lab preparation of, who knows the lab preparation of alkenes? Alkenes, yes? Alkenes, general lab preparation of alkenes, yes? Blood of Jesus Christ. You don't know. They have never taught you people. They have, but you forgot it, Abi. So what are you supposed to do about it? You go and read it again. Now listen. Lab preparation of alkenes is reaction of alkanols. Look, we are saying ethene. You understand what I'm saying? Ethene is ethanol. Propene is propanol. Butene is butanol. Alkene is alkanol. Am I communicating with you? Yes. So in the lab preparation of alkenes, please listen, join me in this. What you do is that you react alkanol with excess sulfuric acid. What did I say you do to get an alkene? React alcohol with excess sulfuric acid. That's to produce alkene. In fact, you can put that down. Yes, put that down. Alkenes are produced by reaction of alkanols with excess sulfuric acid. That one will give alkene. Now, can I tell you where jam might catch you people? As I said, you know, say, as I teach, if that thing just enter my head, I will just talk. So listen, and this one enter my head, so make I talk. Where jam might catch you people is they will now say, what is the product? Sure, you know this one now. That okay, if I react ethene with excess H2SO4, what's the product? Sorry, ethanol with excess H2SO4, what's the product? Ethene. Propanol with excess H2SO4, what's the product? And so on and so forth. But once you see, if they wants to catch it, they will now say excess ethanol reacts with conc H2SO4 to produce dash. Who knows the answer? Excess, you know what we said in producing alkene is excess acid. But now, what if you have excess alcohol and less unlimited acid? What is going to be the product? An ether. What did I say is going to be produced? So put that down. If excess alcohol reacts with conc sulfuric acid, ethers are produced. But the type of ethers we use are referred to as symmetrical ethers. But yeah, you can put it down if you want to. Symmetrical ethers. Symmetrical. 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 Please, what did we say in 18? Alkanol and H2SO4. Who is excess in alkene? Who is excess in alkene? H2SO4, right? Sulfuric acid, right? But in ether, who is excess now? Alkanol. Not both of them. Conc is not excess now. Conc means concentrate. Okay, so I should say it again. Reaction of an alkanol with reaction of excess alkanol with conc H2SO4. You know both of them. When I say sulfuric acid, I meant conc sulfuric acid too. So with conc H2SO4, will give a symmetrical ether. What did I say to give? What did I say to give? Symmetrical means that what is on this side is also on this side. Like human beings, we are bilaterally symmetrical. Are we not? You have eye here, you have eye here, you have nose here, you have nose here. Is it not? What did I say before? Oh, it's not. Is it what? Radial. Radial means that equal to one member. But it's not the same thing. I want to mind them up. Now, let's continue. Bilateral means that you can only get the same thing when you cut it from one end. Then asymmetrical means that there is no symmetry. No matter how you cut it, you not get anything like the same thing. Each of people just visit the asymmetrical. Now, as I was what? Saying, when I say symmetrical ether, it means that you have not decided that, and the method of producing symmetrical ether, that's one you need to. The method of producing symmetrical ether is by what did I say? Reacting excess alcohol with what? Okay, now look at the reactions here. Very, very simple. What did I say? Very, very simple. So look at the reactions here. If you add let's say CH3OH plus H2SO4. I get what I'm saying. What is going to be produced? You know, the whole process of doing this thing is this one will be excess, right? So what do? 2. Am I communicating with you? Now, neglect this guy. Because somehow this guy there eventually is a catalyst. Why is it a catalyst? It is H2SO4 at the beginning of the reaction. At the end of this reaction, what will it still remain? H2SO4. It's not as if it doesn't react to the substance, it will react. There are processes that we don't do this process, just note the beginning and the end. I get what I'm saying. There are things that will happen in this reaction with H2SO4. But the point that makes it a catalyst is that autosidinambo called the when it was going on. But then at the end of it all, it was the same thing. That's what a catalyst does. In solvent process, ammonia is a catalyst, not because it does not react. Why is it a catalyst in solvent process? Because in the beginning of solvent process, you have ammonia. At the end of solvent process, what do you have? Ammonia. Am I communicating with you? Yeah. So now let's continue. Listen. So excess, see what happens here. CH3OH. Listen, and then CH3, I'm going to write it like this, OH. Now, see how this reaction occurs. It occurs by dehydration. Both alkene and ethers are produced by dehydration. What did I say? Both alkenes and ethers are produced by dehydration of alcohol. I get what I'm saying? But the difference is that if you are going to produce an alkene, you will need to use excess sulfuric acid. What does it you need to use? Excess sulfuric. But if it is an ether, what are you going to use? Excess alcohol. Now, see what that excess alcohol does. See how the reaction occurs. Dehydration means you're moving water. And water here is H and OH. Once you eliminate this thing, you will have CH3O, and then this CH3 will now come and join you. Class, what is the name of this thing? Methoxy what? Methane. I should do it again. See this one. C2H5OH You know it's excess now, so we need 2. So let's write OHC2H5. What am I removing? Water. So what is the compound that will be formed? C2H5O C2H5. What is this thing called? Ethoxyethane. Am I complicating with you? Now so they produce ether. So if I say, for instance, what question did I remove? Okay, let me give a question again. I say, what is the product of reacting excess propanol? Excess what? Propanol. With sulfuric acid. What's the answer? Prop. I said prop, not X. So what will it become? Propoxypropane. It's common sense now. Or your excess butanol with sulfuric acid, what will it become? Butoxybutane. In fact, you can put these examples down to help you understand it more. You get, what is, I said write the question. Did you write the question? What is the product of reacting excess propanol with sulfuric acid? Please, class, what is the answer? Propanol. What is the answer? Propoxypropane. Simple. Yes, now. I should say it again. Reacting excess propanol with sulfuric acid give an ether. And what is the ether? Propanol can react. So which will give propoxypropane. If it's butanol, what will it give? Butoxybutane. If it's pentanol, what will it give? Pentoxypentane. It's that simple. So you just need to understand that once you are dealing with excess alcohol, your quantity, excess what? Alcohol. And sulfuric acid, it will give an ether. That's what you need to know. Now, but what if I had said, y'all listen, bro, you cannot sit in this class. I bind that spirit of strips, in Jesus' name. Okay, now listen, guys. Hey, y'all listen. I like doing, one of the things I like doing is, I like simplifying it so that even without too much thinking, you can just grab it, provided you understand the underlying factor. Once you understand the basic thing, then it is easy to grab. Now listen, please listen. The next thing I would like to say is this. Listen, please listen. The next thing I would like to say is this. What if I had given a question and said, ethanol reacts with excess sulfuric acid? What is going to be produced? You see that you are not listening to the question. Now, if you are listening to the question, you will know one of them is excess, right? If alcohol is excess, it will give that alkoxy-alkane. Don't be so. But once the sulfuric acid is excess, it will give alkene. So I take it again. Another question. Listen, check your notes well before I call this question. If it is ether, who needs to be excess? Check. I want everybody to check. Have you checked? If it is ether, who is going to be excess? Very good. Now I have a question. And I say that the question is excess hexanol. Excess what? Hexanol reacts with sulfuric acid to produce what? What's the answer? Hexoxyhexane. Because alcohol in excess plus sulfuric acid will give alkoxy-alkane. Thank you. Now, what if I now say hexanol reacting with excess sulfuric acid? What would that one now give? Hexane. Because once the alcohol is reacting with excess sulfuric acid, it now gives an alkene. But if the alcohol is in excess, it will give alkoxy-alkane. Am I communicating with you? Now, I should come again. Excess alcohol reacting with sulfuric acid gives alkoxy-alkane. But alcohol reacting with excess sulfuric acid will give alkene. So when I say propanol with excess sulfuric acid, what will it give? Propene. But if I had said excess propanol with sulfuric acid, what will it now give? Propoxypropane. Okay, now let's move ahead of this. I am sure that if you look through this again, it will enter very well. Now, let's continue. I was still highlighting some of these things before I was stopped by in-hand now stop home. Now, alkanal. We already know alkanal now. Terminal carbonyl. And terminal carbonyl with carbonyl, C double bond O, then end in a hydrogen. Open the fluid that you see it like this. Please, CHO and COH, are they the same thing? No. Excuse me, CHO and COH, are they the same thing? No. Once you see CHO, you are dealing with what now? So just know that. OH. And besides, the one canal, watch one, listen, open our canal, get it. You see C, the O and the H are together. Am I communicating? Yes. But when you have this C, double bond to O, and then H is different. This is not alcanol. What is this now? Alka. Now. Alka what? Now. Kaigani. One day alkanal behind our phone alkanol. Can you for one day alkanal? Alkanol. Only can non-terminal carbonyl. Non-terminal carbonyl means, oh wow. Okay, you are writing from the board. Terminal carbonyl. I don't think you can see my writing. But yes, non-terminal carbonyl means that the C double bond O is in between carbon chains. Are you getting what I'm saying? So if I write this thing now, CH3, C double bond O, and then CH3. Please, is this an alkanal or an alkanol? Alkanol. Yesterday, we discussed how to differentiate between an alkanal and an alkanol. Who remembers the reaction? What are the reagents you use to differentiate? Solid reagent, Bennett's reagent, and Benedict solution, right? Good. But if I want to identify an alkanal or alkanol, what am I going to use? Radish reagent. And can you simple radish reagent down? 2,4-dinitrophenylhydrazine. It reacts here with alkanal or alkanol. Can you produce 2,4-dinitrophenylhydrazine? What be so? Carbazine reacts. Can you produce? Semi-carbazine reacts. Can you produce? Okay, thank you. So that's that basically. And as I said, there are some questions that they don't enter deep. They just ask you product, color, all those kind of things. That's where how they ask their reactional questions. Am I communicating with you? That's why in some cases, I don't even bother going in between line. I just give you, if this is this is the answer. Because that's how they ask their questions. Am I communicating with you? Good. Now, Kaigani, we are done with alkanol. Keki Gesima alkanol. If one has double, see, you know, this is also written as CO. Hope you know. Hope you know. If you don't know it now. So when I write CH3CO and then write CH3, please, is this an alkanal or an alkanol? Alkanol. Am I communicating with you? Yes. Good. So take note of that. The name of this alkanol is propan 2-O or propanol. Yeah, acetone. Can you select the acetone then, man? I work for nail polish. Am I communicating? Okay. Now let's continue. With this said, we go to the next one. Alkanoic acid. Alkanoic acid is carboxylic group. What did I say? Alkanoic acid. Carboxylic group. C double bond O and then OH. Once you see this thing, COO. See another way to write it. CO2H or COOH. This is alkanoic. Then ester. Ester is what put this hydrogen? COO. Ester is what put the hydrogen? COO. Which means if I see this, or I see this, or I see this, I am still talking about an ester. Then after the ester, amine. Amine is simply carbon direct single bond to nitrogen. Amide is carbon nile, not just carbon, but getting carbonyl to nitrogen, single bond. You remember what I said is the difference between primary, secondary, and tertiary? Yes. Primary nitrogen, primary amine will have how many hydrogens? 2. Secondary will have how many? 1. Tertiary will have how many? 1. Same thing for amide. Primary amide will have how many? 2. Secondary will have how many? 1. Tertiary will have how many? 1. If I know the difference from the Utresia, primary alkanol, secondary alkanol, and then you know it's different now. Primary alkanol, OH will be where? Primary carbon. Secondary alkanol, OH will be where? Secondary carbon. Tertiary alkanol, OH will be where? Thank you. Did I talk about Lucas reagent yesterday? I'm not sure I did. Now, I just said it. Now listen. We said that there are two reactional differences of alkanols. I'll continue. Nitrile, let me just round it up so that we'll just get into this. Nitrile. Nitrile is carbon triple bond nitrogen. Oh yeah, now, get into. Listen. Alkanoate is the same thing as ester. Did you guys hear what I said? Alright, so just take note. Now, get into. If I moved imine yesterday now. Imine is what? Carbon double bond nitrogen. Now, kind of good can continue here. Now, get note. I said there are two reactional differences between primary, secondary, and tertiary alkanols. And the first one I talked about yesterday was oxidation, right? Yes. Good. I said in oxidation, get one thing. Primary alkanol will be oxidized. How many products will it give? 2. It will first give and then give alkanoic acid. Secondary alkanol will give what? Alkanol 1. Tertiary alkanol will give what? Nothing. Am I communicating with you? That's one way. The second way to differentiate them by reaction is using Lucas reagents. So right, Lucas reagents is used to differentiate primary, secondary, and tertiary alkanols. I don't know why you are not writing. Do you already have it? Lucas reagents. You already okay? Written that one. Lucas reagents is used to differentiate primary, secondary, and tertiary alkanols. And it's important to start taking note of these things because one of these reagents must come out. Heisenberg test. Lord of Jesus Christ. What? I'll see the what? Will I? Benzene sulfonyl chloride. Okay. I have to. Yes, it comes out. That's to differentiate primary, secondary, and tertiary amines. Use, Ginsberg or Heisenberg test. We'll talk about it. Don't worry. Let's continue. Now, as I was saying, get into. But all you can come to go is reactional differences between amines and amines. Don't worry, we'll still talk about all these things. Now, you guys are done now. I can wipe it. Now, hey, listen. Y'all listen. Lucas reagent. And Lucas reagent is a mixture of zinc chloride and HCl. And how does it work? First of all, based on reactivity, I hope you know that tertiary alkanols are more reactive than secondary alkanols, and secondary alkanols are more reactive than primary alkanols. Put that down. Secondary alkanols, tertiary, so you can just write this thing. T-nol more reactive than S-nol, more reactive than E-nol. I get what I'm saying. You can just write this down. And one of the reasons tertiary alkanols are more reactive is because they have higher inductive effect. What did I say? That is to say, they are more polar than the secondary and primary. You notice that alkynes are more reactive than alkenes, and alkenes are more reactive than alkanes. You know that, right? Yeah, you did not know. Oh yeah, the phone are just in case. Alkynes more reactive than alkenes, more reactive than alkanes. Actually, kind of that very easy questions like which one of these is the most reactive? And then you give ethane, ethyne, and ethene. Which one is the most reactive? Ethyne. Even with this triple bond on one, it can break how many times? It can break 1, join to 2. Break 1, join to 2, which means it can accept 4 different atoms which means more reactivity. If it was alkene can only accept how many? It can break once and accept how many atoms? 2. But in the case of alkene, you can't break a sigma bond. If you are breaking, you are changing the whole compound. Am I communicating with you? You notice that there is no extra bond to break, which means this one will be the least reactive because it cannot accept anyone. The highest that can happen to an alkane is that our powerful or not also. That is substitution. That is what? So when it is filled, the only reaction that can occur to something that is filled is substitution reaction. What did I say is the only reaction that can occur? That once it's saturated, substitution is what occurs. But once there is a level of unsaturation, you will notice that you can do addition. You can do what? That is, you can break the bond and then form a new bond between new atoms. Am I communicating with you? So, anyways, we've written this. Now, Lucas reagent, how does it work? If you bring Lucas reagent and react it with a tertiary alkanol, once you react it with a tertiary alkanol, you will have that because it is very, very it's the most reactive, right? The reaction will occur immediately. So turbidity will show immediately. Now, open secondary. Lucas reagent plus secondary alkanol. Turbidity will show after 5 minutes. Be right here, now they hear me. Secondary alkanol plus Lucas reagent is there. Turbidity will show after 5 minutes. Lucas, you don't need to understand. You just need to know that anytime Lucas reagent reacts with secondary alkanol, when will the turbidity show? After 10 minutes, 5 minutes. I'm not going to tell you, when will it show? Immediately. Am I communicating with you? Good. Then if it is primary alkanol, no turbidity. What did I say is the one for primary alkanol? No turbidity. So let's take it again. Lucas reagent plus tertiary alkanol. Can I have a photo? That is more reactive. Please, what you thought was wrong. Where's that brother? Thank you. How many minutes are this? So you wait for here. Place your head here for like a while. So wake up. Are you not awake? Now, alkynes. Are you listening to me, brother? Are you listening to me? What are you learning now? Alkynes are more reactive than alkenes. Why? They have 2 fibers. If I write this down, the more the polarity or fiber, the more the polarity or fiber. So, to write this. I'm waiting for the night to come. But while we are waiting, write this. In area. Which one do you want to read? The very first one. The very first one. The very first one from direct message or all the groups I mean. Important info. Improving community. The goats. Indie home medics. Confirmation class 2024. Okay, see the chart. The chart here says. The chart here says. What does it say? My love. If you ever see my love, make I bring. You know PC. Me and my wife in the chat to WhatsApp. I bring. I don't try now. You don't see anything. My sister now. Open her now. And there's no my own. You don't miss anything. Me and my wife, we know they use WhatsApp chat. Understand? I tell her, say, my wife, and a mirror, don't lie, because she will win, she no money. And she don't initiate me to their program. So once I stand on the mirror, I'll say, Alakuta, Alakata, let me get a show. Oh my, go and try it, go to mirror and shout, Alakuta, Alakata, let me get a what? Show. I want to show. Right. Parts of an organic name, right. Parts of an organic name. Parts of an organic name. Man. Oh! I said the more the pi bonds or the higher the polarity, the more the reactivity. Oh, I did not say it like this, but how did I say it? Or pi bonds, right? The more the polarity or pi bonds, the higher the reactivity. Sorry, the higher the, who has this? Is this yours? Open it. The higher the reactivity. Is it yours? Open it now. Let me confirm this yours. I have 3 phones with me. How did I collect this phone? Phone 2 phones. When did that phone side? They went out. Yeah? Open it. Now, as I was saying, where was I? Now let's get to it. Parts of an organic name. Sharp. The fast. Yeah. Should I use? How do I give it one? Because I don't give person phone before. See who are they give am? You give it to this guy. No, raise your hand. They give am back. Go. Because I don't pass phone before. No, na phone I wan see. I don't forget. Give me that phone. Yeah. I said, where is the phone? I don't give me. I'm not joking. It's not in this headset, I was somewhere else. But you don't say that guy give out the phone eventually. People there, they do the she. I say, my uncle, I'm gonna have the phone in the phone. Say, what do you mean? Give me. Yeah, locked door. I don't get power outside. I come here and don't get power in the class. I'm gonna stand up. I'm gonna search everybody with the here. Guys say, the phone, the phone, the phone. Say, I'm not going to phone. What's the phone I there? The guy, unashamedly, brought out the phone and gave it to me. Man, you. Criminals, what did I say? But let's continue. Parts of an organic name. Number 1. If I let me write it down and write the arrangement so that everybody knows this thing. Now, I will not be giving so much note on this. I will just highlight something that you need to know. I will move ahead because I believe you already know this. Get it? The parts of an organic name are, listen, there is a little modification to the naming system I gave last year. Just a slight modification, but it's almost the same thing. The first part is prefix. What did I say is the first part? What did I say is the first part? The prefix will tell you substituents or functional groups of lower priority. Please, what did I say the prefix tells you? Second one is infix. What did I say the second one? The infix is not so popular. Are you listening to me? The infix is not so popular. Please, I am begging us. Let's not use our phones in class. I don't want to see phones again. You get what I'm saying? We are all mature people, so let's respect ourselves. I'm giving a note here, and some of you are just pressing it. It doesn't make sense. I was saying that the next one is what? Infix. Now, infix, it doesn't usually occur. Are you getting what I'm saying? When you talk about your infix, you hear something like cyclohexane. That cyclo there is what? An infix. In the formal note you wrote in my organic class, you call that infix the root word. Are you getting what I'm saying? But then it's a modification now. The infix tells us the orientation of the chain. What did I say the infix tells us? If it is straight chain, round chain, isomerically chain, and so on and so forth. That one is what we call what? Infix. So what does infix tell you? Orientation. After that, you have what we call root word. What did I say you have? Yeah, what's up? The television is off. Okay. Engineer, their television is off. So what did I say is the third one? Now, what does the root word? Please listen to me. If you have this note before, write it again. Yes, I know you already have it. Or what did I say? Write it again. One is the reaction set to be physical and non-physical examples. This is thermochemistry, eh? It's not just thermochemistry anyway. There is feasibility of reaction in electrolysis too. But let me just say, if a reaction is going to be feasible and a redox reaction in electrolysis is going to be feasible, I'm coming back though. But let me say this. Let's say, for nigga water, understand it, but I think I'm going to have to teach it again. Any reaction that is going to be feasible in electrolysis will have a positive EMF. What did I say is going to have? And for it to have a positive EMF, the potential of the cathode has to be greater than the potential of the anode. I think I can just illustrate it in 2 minutes. Listen. My hand, leave it like that. You all know King can now marry. Let's go. King can now marry all Nigerian female slaves, provided he could mercury, silver, gold. Saving lives since 1960. Now listen. The ones that are below have higher standard reduction potential. Please, which ones have higher potential now? The ones that are below. I take it again. The ones that are below have higher reduction potential. Which ones have higher reduction potential? Which ones have higher reduction potential? Thank you. Those that are behind, which one has high reduction potential? Thank you. Now that you've answered that, reduction potential is potential to be reduced. My question is, where does reduction occur? Cathode or anode? Okay, if you don't know, I have this thing I usually repeat often and on. Anodic oxidation, cathodic reduction. Anodic oxidation. That means cathodic reduction. Cathodic reduction. So when you see your neighbor in the morning tomorrow, just say anodic oxidation. Or that again. But if your neighbor is not fine, consider it cathodic oxidation. Meaning no anemia. Meaning again no anemia. I'm still answering a question now. The list of the time. Okay, I'll come to this. Now listen. Please listen. Reduction potential means the one that has the highest chance to be reduced. Am I communicating? And we said that it increases down the group. Which means if at the cathode, listen, I have zinc and lead. Cathode of reduction remember. Between zinc and lead, who has more potential to be reduced? Check now. Who? Lead. So who am I going to use as the cathode? Once I use lead as the cathode, it means that lead will have a higher potential than what? Zinc. Will the EMF be positive or negative? It will be positive because EMF is cathode minus anode. That is potential at the cathode minus potential at what? The anode. So once you use the one with high reduction potential at the cathode, automatically it will lead to a positive EMF. So listen, if I have another arrangement, listen to these arrangements now. I have silver, listen, I have silver and I have aluminium. Who am I supposed to use as the cathode for it to be a positive EMF? Silver. Once you use silver, silver has higher potential as the cathode. It will mean that this particular EMF will now be what? Positive. That's how it works. Am I communicating with you? Now, there's a calculation method, but this is one way you can just look at. If you look at the cell notation, once you look at the cell notation, you can know if this particular EMF will be positive or negative by just knowing this thing I just said. If you use the one with high reduction potential as the cathode, it is going to be a spontaneous process. Am I communicating with you? Now, I have another setup. Let's deal with zinc and copper. Zinc and copper is Daniel's cell, right? Where am I supposed to use copper as for it to be spontaneous? Anode or cathode? Why am I using copper as the cathode? Because it has higher reduction potential. And reduction occurs where? Cathode. Am I communicating with you? Good. Now, please, I want to finish up this thing before I continue. No, I'm not answering any other question again. Sure, you do not understand this thing. Some of you understood, but some of you don't understand, right? Those that don't understand, just don't worry, we'll come back to it. I'll need to do it and fully discuss it for you to get it. But if you grab it, it's easy. Reduction potential, higher ones are below. And once you're talking about reduction, it is the cathode. So the one with high reduction will be used as a cathode for it to be spontaneous. If I use this one as a cathode and this one as an anode, it means that the one with lower reduction is now the cathode, which means you have a lower or negative value. Check it now. If this one is lower than this, let's say we have 2 minus 5. Is it negative or positive EMF? Will it be spontaneous? So when you want it to be spontaneous, use the one with higher reduction potential where? As the cathode. And once the higher one is the cathode, it will minus and give a positive value. Positive EMF indicates what now? Spontaneity. What did I say it indicates? Now, the second thing about spontaneity is in thermodynamics. That one, the G is equals negative. All hexagonic reactions are spontaneous. Let me not confuse you anymore. Let's just consider this. Let's just consider this. Now, what did I say is the third one? Root word. Root word tells us number of carbon. What did I say root word tells us? Number of carbon. In parent chain. In what? Parent chain. In parent chain or subsequent chain. Well, anyway, for now, remove our subsequent chain. Just use parent chain. Now, have you written this down? We all know the normal root words now. 1 is met, 2 is et, 3 is what? 4 is what? 5 is what? 6 is what? Should I write it? Okay, what about 10? 11. 11, on there. 12, go there. 13, try there. 14, what for there? Should I write it? 20. I've got 8 close, 5 close. From 11, right? Yes. So 11, on deck, like on, do, 12, cut it. 12, go there. 13, try there. 14, 15, penta deck. 16, 17, 18. This one here. 19. Non-adec. 20. Decadec or where? Icos. 21. Henny Icos. 22. Docos. 23. Tricos. But you don't need those ones. Now, why you need up to 20 is because, listen, no, fatty acids. Fatty acids are alkaloic acids with 12 and above carbon atoms. Okay, by 12, obviously alkaloic acid. You almost get up again fatty acid. Okay, what did I say? Once the carbon atoms are more than what? 12. It is no more fatty acid. What is it now? It is no more alkaloic acid. What is it now? Fatty acid. Very good. So when you have 12, 13, 14, 15, like your palmitic acid is 16. Don't be so. Yeah, you people do not know these things. Haven't you done soap and saponification before? Yeah. Can you tell us saponification? What is saponification? Production of soap or saponification. It is the alkaline hydrolysis of what? Alkaline hydrolysis of what? Yeah. Alkaline hydrolysis of what? Of what? Okay, now, before Frank, thank you. Now listen. Listen, in the next class we'll just push ahead of that. Listen. Now, the other part is suffix. And in suffix, anyway, primary suffix, careful. Primary suffix. And secondary suffix. What did I say you have in suffixes? Primary suffix and secondary. Now watch this. Please everybody just listen to what I'm saying. Primary suffix describes saturation. That is to say level of saturation, whether a substance is saturated or unsaturated. That's just right, saturation or unsaturation. So let's look at this name now. Watch this name. I have a name on the board. The name is 2-methyl cyclopenta pent 2 or pent 3 enoic pent 3 enal. Now, the first part of this name that talks about the substituent is what we call prefix. Cyclo is infix because it tells us the shape. Am I communicating with you? Then pent is what? Root word, telling us that there are how many carbon atoms here now? Now, kita that you see in, an, ein, those ones is what we refer to as what? Primary suffix. It tells us if a substance has a single bond, double bond, or triple bond. Then finally, this one tells us the functional group. What did I say this one tells us? The functional group of highest priority. What did I say this one tells us now? Of highest priority. We'll continue in the next class. Thank you very much for your time.